Hello, my name is Lauren Hobbs, and I'm the Vice President of Product and Business Development at BlueSpec. Today's presentation is an introduction to BlueSpec's RISC-V processors and tools for Achronix Speedster 7T FPGAs. First, I'd like to provide a little bit of background on who BlueSpec is. So we were founded in 2003 in Boston, where our headquarters are, and we have offices in Seattle and Silicon Valley. We are a founding member of RISC-V International and the Open Hardware Group. And with the emergence of RISC-V, we started to focus exclusively on RISC-V IP and tools. We offer RISC-V hardware acceleration and FPGA-based RISC-V development and emulation tools, as well as silicon IP in the form of RISC-V FPGA softwares and RISC-V ASIC and FPGA processor front ends for hardware acceleration. We have deep expertise in RISC-V and have significant contributions to the RISC-V ecosystem really since its inception. So what is RISC-V? RISC-V is an open standard instruction set architecture. What that means is that it is a non-proprietary processor architecture that serves as an alternative to the dominant CPU architectures in ARM and x86. RISC-V enables developers, users to innovate by implementing their own form of RISC-V processors that adhere to the RISC-V instruction set architecture standard. RISC-V was created in 2010 at UC Berkeley, and then in 2015, RISC-V International was founded. RISC-V now has over 4,000 members across 70 countries. There is now a broad ecosystem for RISC-V. There's many commercial and open source tools, IP, and libraries that are available today, and it is growing very fast and will continue to in the coming years. And RISC-V is really becoming common in the FPGA landscape, with most FPGA vendors offering RISC-V processors in some form or another in 2024. So why would I think about adding a BlueSpec RISC-V processor to a FPGA design? Well, RISC-V processors really enable a number of functions within a FPGA. So it enables the ability to run an operating system, either a real-time operating system or even full-blown Linux. It enables management and control of applications and accelerators at the software level. It provides application monitoring, instrumentation, and logging and reporting capabilities. And allows you to implement complex functions that may be difficult to implement in hardware or debug in hardware by implementing them in software running on a processor. A good example of this would be a complex state machine that gets very unwieldy implementing in hardware, but is much easier to manage at the software level. BlueSpec's RISC-V processors are scalable. All of our RISC-V processors have standard features, but can be tailored based on resource and application requirements. They're also customizable in that you can add custom instructions in the form of accelerators to the processors in a coprocessor port. And BlueSpec's RISC-V processors are also portable, meaning they can be used in Achronix FPGAs, eASICs, and if you eventually go to an ASIC, they can also be used in an ASIC. Okay, so next I'd like to provide an overview of the processor IP that we provide. BlueSpec offers 4 families of RISC-V processors. First, the microcontroller family. Next, the BMR, which is bare metal or RTOS family. Next is the single core Linux family, or the SCL. And then finally, the multi-core Linux family, which is CPU clusters of 2, 4, 8, or 16 RISC-V processors. Going back to the microcontroller family, I'll walk through the feature set of the MCU family. It is a 32-bit processor and has the RISC-V integer, that's the base integer instruction set support, but also provides the ability to add the multiply and divide instructions, compressed instructions, or custom instructions. It is a multi-cycle architecture, meaning that it takes multiple clock cycles to execute an instruction. And it's a tightly coupled memory hierarchy. It is very low footprint and requires 1.6 to 2.2 K 6-input LUTs to implement, and can run up to 330 megahertz. The BMR is the next step up in the family and adds a 5-stage processor pipeline, instruction pipeline, versus a multi-cycle core when compared to the microcontroller. It also has a cache memory instead of tightly coupled memories, and it offers physical memory protection and branch protection. So if you need some more processing power, you can move from the microcontroller to the BMR family, and that will require more resources in the form of 12K to 22K 6-input LUTs to implement, depending on the feature set. It's also worth mentioning that the BMR can come in a 64-bit version, and also adds the ability to add multiplication, atomic instructions, F&D, which are floating point, single and double precision, and compressed instructions. And the range in the resources required is going to be dictated by the feature set and the instructions that are included. The next processor family, the single-core Linux family, is very similar to the BMR family in that it has a 5-stage pipeline, with the fundamental difference that it supports virtual memory and a memory management unit, which enables you to run a complex operating system like Linux. Finally, there is the MCO family, which is a multi-core version of the single-core Linux family, the same 5-stage pipeline, but with a shared cache complex for the multi-core processor subsystem. Okay, now that we know a little bit about the BlueSpec RISC-V processor portfolio, let's talk about how that fits into the Achronix FPGA architecture. So it is highly scalable and configurable. And really, any of the processors that I've mentioned can be attached to any open 2D NOC network access point. And it can be a combination of these processors. You can do one processor or multiple processor complexes if the application requires. Each one of these processors also does have a coprocessor port, so it allows you to add accelerators tightly coupled to the processor in the form of custom instructions. And they can also interface with loosely coupled accelerators, and that would be accelerators that are sitting across the 2D NOC, and the processor communicates through the 2D NOC to the loosely coupled accelerator. All of these processors can be instantiated multiple times, or a combination of these processors as singular processing complex in the system. Cores in the MCU family share memory across coherent memory across the processors that are in that multi-core cluster. So this really is a flexible, scalable architecture that ties nicely into Achronix 2D NOC and provides you the ability to plug and play processing elements as the application requirements dictate. So what does BlueSpec provide with its RISC-V processors? Well, first we provide standard soft processor IP in the form of source code that can be synthesized into Achronix FPGAs. We also provide all the scripting and documentation necessary for taking that source code and developing it for Achronix FPGAs. We also provide the ability to the capability to add custom instructions / accelerators that are tied to the processor, and these can be implemented through Verilog or high-level synthesis. And BlueSpec has tools to help the development of these accelerators and tie that all together to be controlled at the software level. And we also provide a hardware and software development with packaged and tested open source tool chains, including GCC, GDB, OpenOCD, and then also we provide free RTOS and Linux, depending on which processor is being used. And all of this has been developed for and optimized and enabled on Achronix technologies. We have a complete hardware software reference design for the VectorPath card and a hardware-based development environment with the RISC-V tool chain environment, or it's enabled. And in addition to the tools and the source code, documentation, et cetera, that we provide, we are also an experienced partner that is committed to our customers' success. So we work closely to ensure that our customers are successful in implementing the processing subsystems for their systems requirements. If you've been listening to this presentation, you're probably wondering how to get started or how you can get your hands on it. We are starting early access now, and if you do have a customer that's interested in using RISC-V in their next Achronix FPGA design, please reach out to your local Achronix salesperson, and they can work with you to get enabled with an evaluation to get started. And that concludes today's presentation. I'd like to thank you all for your time and look forward to working with you.